Hello and welcome to the full demo of the Tandy MultiFace with me, the Raspberry Pi guy. In this video I'm going to show the MultiFace, some of the many things it can do and explain all about it. First off, what is the MultiFace? The MultiFace is right there, and its official definition is a Raspberry Pi input-output extender, meaning it extends the use of the Pi's GPIO pins. You plug it into your Pi using a ribbon cable, and you can easily program it to interact with the outside world. It brings together a selection of interfacing components onto a single circuit board. This means that it's ideal for experimentation and prototyping, much like the stuff we've done on breadboards, but in a neater, easier and overall much more advanced manner. It's similar to the GURT board in design and shape, and I'm going to be showing you that in a minute, and it's largely backwards compatible with it. In fact, all of the code that I'm using in this video is from the GURT board test suite. Sadly, as of current, it's not available just yet. I'm using the beta board at the moment. It should go on sale soon though, and when it does, you'll be able to purchase it from Tandy. Their website link is in the description below. Here's a close-up of the board, and now I'm going to explain all of the components and how you'll be able to use the MultiFace. The actual populated board, as you can see, it's quite big. Here it is compared to a Model B Raspberry Pi. And also my fingers. You may be thinking, what are the benefits of having a MultiFace, and what can it actually do? Well, the board can do tons of stuff. It has buffered outputs to protect your Pi if you wire up something incorrectly. Those are at the top here. It also has digital to analog and analog to digital converters, which allow you to work with sensors like distance sensors and photo sensors, so you'll be able to sense the amount of light in the room or how far something away is. And those are these two integrated circuits here. It also has a motor driver, which will allow incredibly easy use of a motor or servo, and the terminal to connect a motor is up here. The board also has a selection of open collector drivers down the right here. This means that you'll be able to power and use components that require voltages and currents that exceed the capabilities of the Pi on its own. For example, you'll be able to control relays, and therefore it will make the MultiFace perfect for a home automation project. The MultiFace also has 12 inbuilt LEDs that you can control as well, which are at the top, just here, as well as 3 tactile switches that are yours to use. Those 3 here, labelled S1, S2 and S3. And last but not least, the ATMEGA chip in the bottom left corner. This is a microcontroller that allows for Arduino type programming, and therefore you'll be able to control things in real time, sending the data to the Pi to be displayed. So here's the ATMEGA, and these are all the pins that you use to interface with the ATMEGA chip there. The things you can do with the MultiFace are limitless. When you get the board, it won't actually look like this. It will look like this. Unpopulated with no components on it. And you also get a big bag of components. And this means that you're going to have to solder everything together. If you look at the bottom of this, you'll see there's lots of little shiny pads, and that's where you have to solder all of the components in. I realise that the majority of you will have never done soldering before, but that's not to worry, because soldering is not very hard, and I know it may seem daunting at first, but it's really quite easy. So check the description below for a link to the guide, and you can pick up a soldering iron for £10, so they're not too expensive. Now, how do you actually connect everything up? The MultiFace comes with 3 things to facilitate that. The ribbon cable, here, which allows the connection between the Raspberry Pi and the MultiFace. So you connect it to the MultiFace up here, and then the Raspberry Pi's GPIO pins here. And it also comes with a set of female-to-female jumper wires and also quite a few jumpers. Now, a female-to-female jumper wire looks like this, so you'll be able to connect things across the board. And a jumper, or they're sometimes referred to as shunt jumpers, look like this, which means that you'll be able to connect pins that are right next to each other. So basically that's just a plastic coating with metal inside it. Once everything is connected, you can then program the MultiFace through pretty much any programming language. I'm going to be using Python, but you could easily use C or C++. In the next part of the demo, I'm going to show you all the things that the board can do. Please note that I'll probably not cover everything, just most things. And if you have a question then, please comment below. I'm going to show you the LEDs program, which will flash all 12 of the onboard LEDs, apart from number 7, which are programmed to stay on all of the time. So here we go. Now I'm going to show you the multiface with the 3 inbuilt push buttons wired up. So as you can see, I've just got the jumpers over there. Very simple, only 3 jumper wires needed. And what's going to happen is on the left of your screen you're going to see what's been displayed on the Pi, which is numbers that will change when each button is pressed. And on the right side of your screen, which is what you're seeing right now, you will see 3 LEDs come up, and whenever I press a button, one of those LEDs will go off. So here we go. 3 LEDs come on. Now I will show you the analog to digital converters on the multiface with an LDR, also known as a photosensor, so I'm going to be able to sense the amount of light in the room. As you can see, I have my LDR on a breadboard to the right hand side, connected to a 1 kΩ resistor, which is then wired up to the converter on the multiface. First off, a bit of information about the analog to digital converter on the multiface. It is a 10-bit integrated circuit, and so that means that you'll be able to get a reading between 0 and 1023. I did another tutorial a while back using the PCF 8591 analog to digital converter, but that was only 8-bit, and so the reading we got was between 0 and 254. Also, the analog to digital converter has 2 channels. This means that you'll be able to use 2 analog inputs simultaneously. For example, you could use a photosensor like the one I'm using now, and a distance sensor. I will now show you the converters in action. So as you can see, I'm using channel 0 of the converter. When I click enter to run the program, you're going to be able to see 4 digits which represent the reading, as well as hashes next to it so you can visualize the amount of light in the room. So this is without the light on, and this is when the light is on, off, on. So you can see the hashes go up and down depending on whether the light's on or not and how intense the light is. So if I move the light nearer to it, then they're going to go up. If I move the light further away, the reading's going down. Now I will show you the open collector drivers on the multiface, and I'll make them drive a 6-volt buzzer that will make an appropriately annoying noise. Many of you will be thinking, why do we need open collector drivers? As I said before, they allow you to drive components that exceed the voltage and current that can be provided by the Pi. But what does that actually mean then? If I wanted to light an LED, for example, I'd be using the Pi source of power, because an LED is very low powered. But say I want to control a 230 volt light bulb. The Pi could not possibly power that, because the maximum voltage any component connected to the GPIO pins can draw is around 3.3 volts at maximum 20 milliamps. So what the open collector drivers allow you to do is supply your own power but still retain control over your component, in our case the annoying buzzer. The board has a total of 7 open collector drivers, and in this program we will hear the 6-volt buzzer being turned on several times. Here we go. In this part of the demonstration, I shall demonstrate the multiface's motor controller with this 6-volt geared motor. As you can see, I have my motor suspended so you can see it, and there is also 4 AA batteries in the bottom right hand corner. These power the motor. The motor controller makes good use of the PWM pin on the Pi. PWM stands for the pulse width modulation, and this is essentially what changes the motor speed. In this program that I'm about to run, the motor will gain speed turning anti-clockwise first, and then reduce speed before changing direction and doing it again. This is the last demo, and I will now show you the ATMEGA chip on the MultiFace with some RGB LEDs. But first, some information about it. The actual ATMEGA is a 328p. Several Arduino boards are based on the same chip. You can Google it. And this means that you can easily program it in the Arduino Integrated Development Environment pictured. Much like the stuff we've been doing with my Arduino Mega, or many of you will probably have Arduino Unos and Nanos. But what is the point of the chip? It effectively turns your MultiFace into a functioning Arduino as well. This means that you could upload code to the ATMEGA and run it separately from the Pi, or have a sensor wired up to the 328p, but instead of feeding the information back into the 328p, you could display it on the Pi's screen. The chip gives you 14 digital inputs and outputs to play with, and as well as 6 analog inputs, so it vastly increases the amount of IOs in your use. Now I'm going to upload some code from the Arduino IDE to the ATMEGA, which will make these LEDs flash between red, green and blue. With my demo of the Tandy MultiFace, the Raspberry Pi input-output extender. Personally, I think that is a fantastic add-on board that no Raspberry Pi is complete without. As I said, they aren't available just yet, but when they are, you're going to be able to purchase them from Tandy. Their website is www.tandyonline.co.uk. And when the MultiFace does become available, it should be around £26.99. In the meantime, I suggest having a look at Tandy's website. It is full of electronics kit that is great in value and of excellent quality. Most of the stuff in this demo and in my tutorials is from their fantastic online store. Before I finish, I have to thank both Darren from Tandy for sending me the board. Without him, this wouldn't have existed, and also Alex Eames from Raspberry.tv for helping with getting my MultiFace up and going. Thanks. If you have any questions about the MultiFace, then as I said, do not hesitate to comment below. I'll answer them to my best of my ability. When the MultiFace is released, you can look forward to a whole plethora of tutorials on it. And that's all, folks. Thanks for watching. Please subscribe and watch my other videos. Bye.